In this demo, we're going to go ahead and enable SSH public key authentication on a Linux host. Now what this means is that instead of signing into Linux remotely to manage it using a username and password, instead we'll still specify a username, but instead of a password, we'll have to have a private key in our possession on our machine that matches a public key stored on the server, hence public key authentication. So the first thing we'll do here is make sure our Kali Linux virtual machine is running in VMware and fire it up and go ahead and log in with username Kali and password Kali. So after we've logged in, then what we're going to do basically is we're going to go to a terminal command prompt here in Kali Linux so that we can make sure the SSH service is started, and then we'll go ahead and generate a public and private key pair. Now here in VMware, what I'm going to do is in my menu, I'm going to go down to View and choose Exclusive Mode. So all I see on the entire screen is really just Kali Linux. And at the top, I'm going to click on the Terminal Emulator command line icon. That'll open up my command prompt, where the first thing I'm going to do is run sudo service SSH start. Now I'm using the sudo prefix because I need to run this with elevated privileges, and the first time you do this, it'll ask you for the password for your current user account. Current user is Kali. We know that the password is Kali as well, K-A-L-I, so I'm going to go ahead and enter that. Now I'm going to use the up arrow key to bring up that command, but I'm going to change start to status to make sure that SSH is active and running, and it is. Okay, now normally what you would be doing is you would be using SSH from another machine to test this, but in our lab environment, we're just going to use the same machine as if we were elsewhere on the network connecting via SSH. So to do that, I'm going to click to open up another terminal emulator command line window. Now, according to step 3 in our exercise, what we're doing here is we're running the SSH command. We're SSHing or connecting to our local host, and normally you'd be connecting over the network to either a host name that can be resolved to an IP or the IP of the SSH server you're trying to connect to. Here we're just testing it locally in our lab. -L for login, and the login name is Kali. So I'm going to go ahead and do that. It asks me if I want to trust that host, so I'm going to type in yes, because I know it is the host that we are connecting to itself, the one that we're working at. And of course, it'll ask for the password for that account. So the password for user Kali, of course, is Kali. All we're proving here is that we are logged in via SSH where we were prompted for a password. We specified the username on the command line with -L. Okay, so we know that that works is the point. We know SSH is working. So I'm going to go ahead and type exit to get out of that. Now the next thing is we're going to configure SSH public key authentication according to step 4 in the exercise. And to do that, what I want to do, I'll just clear the screen with clear, is I'm going to run SSH-keygen to generate a public and private key pair. Now it asks me the path and file name for the key. Now technically this is the private key file. So it wants to put it in /home/Kali, that's my current user's home directory, in a hidden directory called .sh. In Linux, hidden directories and files start with a dot or a period. And in that hidden .sh directory in my home account, it's going to make a private key file called ID_RSA. I can change the file name, but I'm going to accept the default. It wants me to specify a passphrase for that private key. So in our lab environment, we're just going to go ahead and put in Kali. Normally, you'd use a more complex password in accordance with organizational password policies. Now, if I'm not already in my current user home directory as per step 5, I can just type CD for change directory and press enter. And if I were to type print working directory, in other words, PWD, it'll return, in this case, /home/Kali. So I'm already in my home directory. So I'm going to clear the screen with the clear command, and I'm going to change directory to .sh. That's the hidden directory where if we type ls to list files, we'll have our private key file, that's ID_RSA, and our public key file, ID_RSA.pub. That's the public and private key pair. Now the public key needs to be in this directory on the server, and the private key can also be here, but really it needs to be on the station that we will be connecting from. We need to have it in our possession. So normally what we would do as per step 7 is that when you create a key pair, let's say we generated this key pair on a different computer, not the server. Well, we'd have to make sure the public key was copied to the server. And specifically, it has to be in a file as per step 7 in the exercise. It's a text file called authorized_keys, and that file needs to be in the .ssh folder. So even though we generated these keys, the public and private keys, on our local host, we're going to assume in our example that they were perhaps generated elsewhere. So what you would do then to copy that ID to the server, the public key, is you would use the SSH-copy-ID command. Now, we're going to change up our command here. So SSH-copy-ID-L, and then I'm going to specify our current location. Now we could, because we're already in the .ssh directory, I can just refer right away to the public key file that we want to copy to the server. Again, we are at the server, but let's assume we're at a different host over the network. I can specify the user I want to log in as, and then an @ symbol and the IP or the name of the host I want to copy this to. Okay, so at this point, I'm going to press enter. Now, if you've generated these keys on a machine other than the SSH server you want to connect to, you have to get the public key up to the server. Now, let's pretend that it's not already there. So what you would do then from that machine is you would run the SSH-copy-ID command with the -i parameter. You're specifying the ID file. Now, the ID file on our machine right now, we can specify the full path as per step 7, but here we're already in that location. I'm just going to specify the name of the public key file, id_rsa.pub, and then we have to specify where we want to copy that to. So in our example, we would specify a username, in this case, Callie, and then either the name or the IP of the host you want to copy the public key to. In this case, we're just testing this all locally, of course, so the local loopback IP for our Kali Linux VM is 127.0.0.1. Now I'm asked if I want to trust the unique fingerprint for that server. I do trust the server, so I'm going to go ahead and type in yes and press enter. So the idea here then is that it's asking me for the password for the user account I specified in the command line. So that's Callie, of course. Okay, so now let's clear the screen, and if we go ahead and do an ls as per step 8, notice we have a file here called authorized keys. Now the SSH copy ID command created this and copied the public key into it. So as per step 9, why don't we view that using the cat command, cat authorized. Now you can use tab completion. I typed in auth, A-U-T-H, and press tab, and because that's a unique enough file name prefix, it knows the file I'm talking about, so tab completion can save you time instead of typing everything out. And if I go ahead and view that file, this is the public key that was copied here. So let's test this out, shall we? So what I want to do is I'm going to minimize this. I want to go back to my other terminal window that we had open previously to test this out. And what I'm going to do is I'm going to run SSH localhost. I want to open an SSH session to the local host. Again, we're only doing this in the lab. Realistically, you would be doing this from a different computer. But -L for login and the username is Callie. Notice it's not asking for a password for my user account. Instead, it's asking for the passphrase for the private key. So if I go ahead and enter Callie, it's done. We are now currently signed in using SSH public key authentication.